Welcome to the Curvature Amateur. My name is Louis Montagne, and today we're going to be looking at some smokers. Not cigarette smokers, not pot smokers, not ice smokers either, but some big chimneys. And we're going to be observing that from Connecticut. Let's take a little closer look. Alright, so I was standing by Bridgeport here on the peninsula of Lordship, Stratford Lordship, and I'm looking across the Long Island Sound towards this area here. Okay, let's look at my observation point where I was observing from. Right there by the seawall. By point, no point. And you can see that there's a little beach here. And the beach looks pretty much flat. Nobody's gonna get tired walking out of this water. And there's a couple of people standing here, and that's where I was with my camera, Nikon P900, and my little tripod. So my camera eye was about 10 feet over the water level. And I'm looking across the Long Island Sound, about that way or so. Okay, and I'm looking at those big chimneys. They're called the Smokestacks, the Northport Smokestacks. These guys here. Okay, let's take a look on Wikipedia. What are the Northport Smokestacks? 4 tall chimneys, and they stand 600 feet tall. What's that? Where do I have that? Yes, I want to scroll away. I don't want to pay you. Anyway, we got 600 feet here on the Northport Smokestacks. Let's go back to our map. And let's take a closer look at what we can see. Okay, you can see this is the water level. Okay, to here. And the ground looks very short. Not much elevation. Over here there's a little dam. It's separating the used water that flushes back down into the Long Island Sound. Okay. And we can see that on the ground level here, there's a small building. It's got maybe 2 floors. I see 1 floor. And the second floor, you can see the windows here, so it's clearly 1 floor. Okay. So we got like 1 floor, 2 floor. They're pretty tall floor looking like, And here there's a doorway, and you could probably figure out that there's 1, 2, maybe 3 more floors. So we're up to 1, 2, plus 3, about 5 floors to get up to this level. Okay? If you notice, there are little doors at the base of those square towers, which are at the base of the chimneys. So those 4 square towers, they look mostly square above the long roof. Okay, remember this long roof here. Okay, and look at the shape of this building. It looks pretty much square. So the width of the building looks a little bit shorter than the height. Okay, but it looks pretty much like a square. And remember these doorways. Remember this long red building. Okay. If you know height of trees, most trees, I climb trees, I cut trees. Most mature trees are around like 40 feet tall or so. So if we got 5 stories here and this thing is about 40 feet tall, you could say that maybe this is 12 feet times 5, about 60 feet tall up here. Does that make any sense to anybody? Okay, let's look at the elevation of that area. Here we're in New York. We're not that far away. Huntington. And the Northport Smokestacks are right about here. Let's go take a closer look. Yeah, see, that's where the water comes in, and the used water flushes out this way, and the little dam we saw is about here. And we can see, I only see 3 chimneys, but it should be the Northport Smokestacks. So let's look at the ground elevation here. What did they say? 13 feet. Okay. Another sample, again, 13 feet. 13, all right. We can start with that. 10 feet. All right, so it gives us a good idea. All right, say like 13 feet here plus 60 feet, so we're up at 73 feet here or so, or maybe 75 or 80 feet if you want. Or you can even say 100 feet is the top of this long building, if we want. If we want to be generous to the losers that call themselves scientists, I'll show you why they are losers. Okay, because we're going to see, according to the Earth calculations, okay, if you want to calculate the Earth curvature, there are many websites on Google that you can choose from, and they basically give you all the same formula, which is 8 inches to the squared mile. So you got to square the number of miles and distance you measure. So I like to use this one here because it has a little drawing. It has a nice little circle here that represents the ball Earth. And they give you the radius of the Earth, which is 3,963 miles. Okay, remember this number, very precise here. It's not 3,900, it's not 4,000 miles, it's 3,963 miles, says Robert, the expert here, who was asked by others at all levels. Okay, Robert used the Pythagoras triangle, a squared plus b squared equals c squared, and he only used 1 mile of distance. Okay, so he squared that mile. 1 mile square is 1, and then he figured out that in 1 mile you cannot see anything below or shorter than 7.98 inches. So you shouldn't be able to see anything taller than 8 inches approximately at 1 mile. Okay, but here we're more than 1 mile. So let's see how many more miles we are away from. Let's measure the distance between where I was observing from to my observation point. If I turn it a bit like this, you see I was here. Here, measure distance to the smokestacks. So we're 19.16 miles, okay? Let's pull out the calculator. Okay, so we're at 19.16 miles. We gotta square that number. We gotta multiply it by the same number, so we get 367. Okay, so we multiply that by 2/3 of a foot, which is 0.6666. So we're not supposed to see anything below 244 feet at this distance. Go back to the Earth calculator here. The calculator. There you go. All right. So just to remind you, why did it go away? All right. So the value of 2/3 here, I just want to remind you that what the value of 2/3 here is 2 divided by 3 is 0.6 periodical. Okay. 8 inches in a foot is the value of 2/3, the same thing. Okay. And now we get 7.98 inches into a foot. What is that value? 0.665, so it's just a little bit smaller than 2/3. Okay, now let's go back to our distance here with the calculator, and let's do it again. 19.616 miles. Square that number. Okay, we get 367. We multiply that by 0.665. 7.98 inches to the foot. So we're not supposed to see anything shorter or below 244 feet. Okay, as I'm looking across the Long Island Sound. And my camera eye is about 10 feet over the water level. And remember, we shouldn't be, what we figured out of the top of the long red roof was shorter than 100 foot. Okay, let's go see what I'm talking about here on my shot I got with my Nikon P900. Okay, we can recognize the Northport Smokestacks out in the distance and the Stratford seawall where I was standing from. Now let's go take a closer look at those guys. You could have seen that from small, but let's go take a closer look and see the 600 feet tall chimneys. You can definitely see their top easily. Okay, so what are we looking at here? Remember those square towers over the long red roof? Oh, where is the long red roof? Somehow it got hidden by the curving water of the Long Island Sound. The curvature of the earth here is eclipsing that long red building, and we don't even see the little doorway on each top. But if we observe what we're seeing here, we see pretty much of a square. Look at the width of the building. It's pretty much the same as the height of the building. You see that square? I would even say that it's a bit narrower than it's tall. Am I right or am I wrong? So we don't see anything below that. We don't see the long red roof. We don't see the treetops. We don't see the ground there or any cars parked. So the earth is not flat. Just from this little conclusion. If it's not flat, doesn't mean we live on a ball. If I look at my knee looks like it's curving, but does it make me a ball? Even though the sun looks like a ball, the moon looks like a ball, does it mean the earth we're standing on is a ball? If you look at somebody's head, it looks pretty round. Are they a ball? There's a curve. Anyway, how long are we going to be arguing with that? I got other videos to show you these details, not just about the smokestacks. I got some about New York. Most of my videos are home in Hawaii. So there we go. We got proof here that we're not on a flat earth. And we shouldn't be like, I mean, we shouldn't be able to see anything below 230 some feet. Where's the calculator? We shouldn't be able to see anything below 244 feet at 19 miles away, but we still see at least, you know, we're hiding at about less than 100 feet. We're hiding less than 100 feet, and we're supposed to be hiding 244 feet. Does that make sense? I would say we're hiding about 75 feet here, and we're supposed to be hiding 244 feet. That's a big difference using math. You ever use math to find accuracy in your life? That's not what I want to show. Huh? Are these maths precise to you? Would you rather use some other formula to calculate the Earth curvature if you can find one? But no, that's all we got. That's all I got for today. Please watch my other videos. I'm the curvature amateur. I'm not an expert like Robert. I'm an amateur. You don't have to believe me. You just have to go out there and make your own observations. It's easy. Get a good camera, pull out your calculator, and make your research. If you can fit us on the globe, congratulations. In the meantime, we'll look for something else to stand on. Thank you and aloha.